This is ChainMind, the decentralized AI network built for everyone. Just search ChainMind on Google, sign up, download the app, and you're in. That's it. You've joined the network. Run it on any device, phone, laptop, or server. Why ChainMind? Fully decentralized, fully yours.
Imagine a litter box that not only scoops the mess but also whispers secrets about your cat's health before the first symptom shows up. What if the device could spot a urinary infection in the middle of the night, suggest a water-rich diet, and do it all without ever sending a single data point to a corporate server? That future is already knocking on our doors, and the key to opening it lies in a technology most pet owners have never heard of: decentralized AI. The first wave of smart litter boxes arrived with a promise of convenience. No more nightly scooping, no lingering ammonia, a sleek gadget that learned when your feline friend preferred to do its business. Those early models used simple sensors, weight plates to register a cat's presence, motion detectors to count visits, and a basic gas sensor to flag odor spikes. The data stayed inside the box, and the device would flash a light or send a push notification when the litter ran low. It was a neat trick, but the real magic began when manufacturers started plugging those raw signals into cloud-based machine learning services. Suddenly, the box could say, "Your cat's visit frequency has jumped 3%, possible early sign of FLUTD," or "odor composition suggests a urinary tract infection." The allure was undeniable, a tiny piece of hardware turning into a health monitoring assistant. Yet, behind that glossy marketing copy lurked a set of trade-offs that most consumers never see. Every time the box streams weight curves, motion timestamps, and odor readings to a remote server, it hands over a detailed portrait of a private household. That data becomes a target for hackers, a commodity for advertisers, or a liability under data protection regulations. Moreover, the reliance on a centralized cloud introduces latency. A health alert that must travel through several network hops can be delayed by seconds or even minutes, and in the narrow window when early intervention matters most, those delays can be costly. Finally, the per-inference fees charged by cloud providers add up quickly, especially for multi-pet families or manufacturers trying to scale globally. The promise of smart litter boxes is solid, but the underlying architecture is brittle. Enter decentralized AI inference, the engine that powers ChainMind's network. Instead of sending raw sensor data to a single data center, each device runs a lightweight model locally to extract a compact feature vector. Think of it as a fingerprint of the cat's recent activity. That fingerprint, encrypted end-to-end, is then dispatched to a peer-to-peer swarm of compute nodes scattered across the internet. Those nodes collectively evaluate a much larger, more sophisticated health prediction model, validate each other's work with cryptographic proofs, and return a confidence score and actionable recommendation. The raw data never leaves the household. Only the abstracted, encrypted features travel, and even those are shielded by zero-knowledge proofs. Because the computation can happen on a nearby node or even on the device itself, latency drops from seconds to milliseconds, making real-time alerts a reality. And instead of paying a cloud provider per request, the device settles a microtransaction in ChainMind tokens, paying only for the exact compute it used, often at a fraction of traditional rates. Why does this matter for pet tech right now? Early detection of feline lower urinary tract disease, kidney issues, or stress-related behaviors can be the difference between a quick vet visit and a life-threatening emergency. The data needed to spot those patterns, how long each visit lasts, subtle shifts in weight distribution, minute changes in ammonia concentration, are inherently personal. Owners want assurance that this intimate health data stays at home, not floating in a corporate data lake. Decentralized AI delivers that assurance by putting privacy at the core of the design. An edge-first processor inside the litter box captures the raw signals and immediately encrypts them. The encrypted payload is then handed to the chain mind network, which runs a more complex model trained on millions of anonymized cat interactions. Because the model itself is stored as a hash on a tamper-proof ledger, owners can verify that the exact version they consented to is the one being used, eliminating any hidden updates or backdoors. Every inference is logged on the blockchain, creating an auditable trail of health alerts that can be presented to a veterinarian as a verifiable health diary. Building a decentralized smart litter box isn't science fiction, it's a practical engineering challenge that can be tackled with today's components. Picture a device equipped with load cells that measure the cat's weight down to a gram, infrared beams that capture entry and exit timing, and a low-cost metal oxide sensor that tracks ammonia levels. A modest ARM Cortex-M microcontroller, perhaps augmented with a tiny neural processing unit, runs a 10 megabyte TensorFlow Lite model that processes those streams every few minutes and spits out a 20-dimensional feature vector. A Wi-Fi module, hardened with TLS and a lightweight API, encrypts the vector and pushes it to the chain mind network. The network's swarm of volunteer nodes, ranging from idle home PCs to dedicated edge servers, host the full 50 megabyte health prediction model. They validate each other's calculations using zero-knowledge proofs, return a confidence score, and suggest an action such as increase water intake by 10% or schedule a veterinary checkup within 3 days. The cat owner receives this insight instantly on a mobile app that displays real-time metrics, historical trends, and a signed alert that can be shared with a vet. The whole pipeline preserves the convenience that made the original smart box popular while adding a layer of intelligence that respects privacy and scales effortlessly. A crucial piece of this puzzle is how the health model itself gets trained. Traditional AI pipelines rely on centralized data collection. Owners opt in, their logs are uploaded, and a corporate team curates the dataset. Decentralized learning flips that paradigm. Each litter box can train a local copy of the model on its own data, then share only the gradient updates, tiny, anonymized weight changes, with the network. Chain mind aggregates those updates, refines the global model, and pushes the improved version back to every device. Because no raw sensor data ever leaves the home, privacy is preserved by design. Moreover, ChainMind's token economics can incentivize owners to contribute their updates, rewarding them with tokens that can be used for premium features or simply cashed out. This creates a virtuous cycle. Higher quality data yields a better model, which in turn provides more accurate health alerts, encouraging more owners to stay in the loop. When a novel health concern emerges, say a new strain of feline coronavirus, the network can quickly distribute a patched model to every connected box, ensuring that the devices stay on the cutting edge without a single firmware rollout from the manufacturer. For manufacturers, the shift to decentralized AI is more than a technical upgrade, it's a strategic differentiator. By offloading heavy inference to a peer-to-peer network, companies eliminate the need to maintain costly server farms or pay per inference fees to cloud giants. In regions with strict data protection statutes like GDPR or CCPA, a privacy-first architecture reduces compliance overhead and legal exposure. The transparent, blockchain-backed health alerts build brand trust, turning a functional gadget into a trusted health partner. Companies can also unlock new revenue streams. A basic litter box might be free or low cost, while a subscription tier unlocks advanced analytics, personalized diet recommendations, or integration with other pet care devices. All of that runs on the same decentralized inference layer, keeping marginal costs low and margins healthy. Naturally, the idea of a decentralized network raises questions that deserve honest answers. First, reliability. Can a pet owner trust that the inference will be accurate when the network is made up of volunteer nodes? ChainMind tackles this with a reputation system similar to proof-of-stake validators in blockchain ecosystems. Nodes that consistently deliver correct results earn higher trust scores and are preferentially selected for future tasks, while underperforming nodes are penalized or excluded. Second, energy consumption. Edge inference on a microcontroller uses only milliwatts, and the compute nodes in the network are typically idle servers or hobbyist machines that would otherwise sit unused. The overall energy footprint can actually be lower than that of massive, centralized data centers that power traditional cloud AI. Third, user experience. Because the inference happens locally or on a nearby node, alerts appear in near real-time, and the mobile app can cache results for offline access, ensuring a smooth experience even if the internet connection flickers. Finally, model transparency. The model's hash stored on the ledger lets owners verify that the exact version they agreed to is the one delivering predictions, eliminating fears of hidden or malicious updates. But here's the part most people get wrong. They think decentralized AI is only about privacy, and that the performance gains are marginal. In reality, the combination of edge processing, near-zero latency, and a collaborative compute pool can transform the entire pet tech ecosystem. Imagine not just a litter box, but a whole suite of devices: smart feeding bowls that monitor portion sizes, water dispensers that track hydration, wearable collars that capture activity and heart rate, all feeding encrypted feature vectors into the same decentralized inference layer. The model could cross-reference waste patterns with water intake and activity levels, delivering a holistic health score, flagging early signs of diabetes, or even predicting behavioral issues before they manifest. Because the data interchange format is standardized, protobuf messages signed with cryptographic proofs, any third-party developer can plug new sensors into the network without reinventing the inference pipeline. The result is a modular, interoperable pet health platform that scales across brands, devices, and geographies, all while keeping each cat's data locked inside the home. The bottom line is that the next evolution of smart litter boxes, and pet tech at large, will be defined not just by convenience but by the depth and trustworthiness of the insights they provide. Decentralized AI inference offers a concrete pathway to that future, marrying real-time health monitoring with data sovereignty. For manufacturers, early adopters will gain a competitive edge, lower operating costs, and a compelling brand narrative. For cat owners, it means a litter box that does more than scoop. It becomes a silent guardian of feline well-being, powered by a network that values privacy as much as accuracy. At ChainMind, we're already working with forward-thinking pet tech startups to pilot these concepts. Early results show inference latency under 100 milliseconds, zero data leakage, and a 30% reduction in cloud spend compared to traditional SaaS models. As more devices join the network, the collective intelligence will only grow, creating a comprehensive, decentralized health platform, one whisker at a time. If you're a pet tech developer, a cat lover curious about the future of AI, or simply someone who wants to see data privacy become the norm rather than the exception, follow ChainMind. Join us as we build the infrastructure that will let every smart pet device become a trusted, privacy-preserving health companion. The future of pet health is decentralized, and it starts with you.